next one, the series for minus x square cos 2x. So we know that cos x has the series 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial minus x raised to 6 by 6 factorial plus etc. So that is summation n equal to 0 to infinity minus 1 whole raised to n x raised to 2n by 2n factorial. Now in place of x we have 2x here. So minus x square cos 2x will be equal to minus x square summation n equal to 0 to infinity minus 1 whole raised to n 2x whole raised to 2n by 2n factorial income. So that will be summation n equal to 0 to infinity. So taking minus 1 inside, we will get minus 1 whole raised to n plus 1. Then we have 2 raised to 2n here. So that is equal to 4 raised to n. So we have 4 raised to n. Then there is already an x raised to 2n. Then multiplying this x square, we will get x raised to 2n plus 2. Then on denominator, we will have 2n factorial. So this will be the required series. And next one, we need to find the Taylor series for the function f of x equal to sine x about a equal to pi. So if we take f at 0, sorry, f at pi, f at pi will be sine pi. So that will be equal to 0. Now f dash of x will be equal to cos x. So f dash of pi will be, so cos pi will be equal to minus 1. Now the second derivative will be again minus sin x. So f double dash of pi, again sin pi is 0. So this will be 0. And the third derivative will be minus cos x. So third derivative at pi will be minus of minus 1. So that will be equal to 1. Now f4, fourth derivative will be, now derivative of cos will be minus sine. So that is again sin x. So we will again start with sin x and these values will continue. So f4 at 0 will be equal to 0. Now the next value will be minus 1, then 0, 1, 0, so on. So therefore the series is, so the series will be, so first term will be 0, then second term will be x minus pi by 1 factorial into minus 1 will come, then the second term will be 0, then third term will be 1 into x minus pi whole cube by 3 factorial, then the fourth term will be 0, again the fifth term will be minus 1, so minus 1 x minus pi whole raised to pi by 5 factorial plus etc. So the first term will be negative, then positive, negative, so on. So we will have minus x minus pi by 1 factorial, then plus x minus pi whole cube by 3 factorial minus x minus pi whole raised to 5 by 5 factorial plus etc. So that will be summation n equal to 0 to infinity. So we have minus 1 whole raised to n plus 1 will come, then x minus pi. Now we have only the odd powers. So the power will be 2n plus 1 here by 2n plus 1 factorial. So this will be the series for sin x about a equal to pi. And next one, we need to solve the initial value problem and mention a type of given differential equation. So here we can write y dash as dy by dx. So dy by dx equal to, so taking 3 to the right side, so we can write this as 3x square y. Now this can be again written as dy by y equal to 3x square dx. Now this will be in the variable separable form. So this is a variable separable equation. So the solution is obtained by integrating on both sides. So integrating So we'll get, so integral of dy by y will be log y. So integral of 3x square will be x cube plus c. So this will be the solution. Now we are given that y at 0 is equal to 5. So substituting the value, so we'll put x equal to 0 and y is 5. So log 5 is equal to 0 plus c. So c will be equal to log 5. So therefore solution will be log y equal to x cube plus log 5. So that will be the required solution. And now this differential equation can be written in the form, so dividing throughout by x, so we can write this as y dash minus 2 by x y equal to x square. So this is a first order linear differential equation. So it's a linear differential equation of first order, and here the integrating factor will be e power integral p dx. So that will be e power integral minus 2 by x dx. So we'll get e power minus 2 log x. So that will be e power log x raised to minus 2. So we'll get 1 by x square. Now the solution of linear differential equation will be y into integrating factor. So that is 1 by x square equal to integral of q. Q will be the right side function. So that is x square into integrating factor dx plus c. So this will be the solution. So we'll get y by x square equal to, now here x square will cancel off, so we'll get integral 1 dx. So the integral will be x plus c. So therefore the solution will be y equal to x cube plus c x square. Now we are given y at 1 equal to 4. So putting x equal to 1 and y equal to 4. So we'll get 4 equal to 1 plus c. So c will be equal to 3. So therefore the required solution is y equal to x cube plus 3x square. So that will be the solution. And the next one, this is again a linear differential equation of second order with constant coefficients. So this is a homogeneous. So here the right side will be 0. Now for finding the solution of this, we will put y equal to e raised to mx. So y dash will be m e raised to mx and y double dash will be m square e raised to mx. So we'll get, upon giving this values, we'll get m square plus 6m plus 9 e raised to mx equal to 0. Now e raised to mx cannot be 0. So that will give us m square plus 6m plus 9 equal to 0. So this is called as the auxiliary equation. Auxiliary equation will be, so this will be m plus 3 whole square equal to 0. So m will be equal to minus 3 minus 3. So we have real roots and they are repeated. So in that case, the general solution will be y equal to c1 e raised to minus 3x plus c2 x e raised to minus 3x. So that will be the solution. Now we are given two conditions, y at 0 is 2 and y dash at 0 equal to minus 5. So let us find the solution satisfying these two conditions. So when y at 0 equal to 2, so putting x equal to 0, we will get, so e power 0 will be 1, so we will get c1, and since x is 0, the c2 term will go, so we will get c1 equal to 2. Now y dash will be, so let us take the derivative of this, y dash will be minus 3 c1 e raised to minus 3x plus c2. Here we will have the product rule. So we have e raised to minus 3x plus minus 3 x e raised to minus 3x. So y dash at 0 will be minus 3 c1 plus C2 equal to, so y dash at 0 is -5, so this is -5. Now we already have C1, so -6 plus C2 will be equal to -5, so therefore C2 must be equal to 1. So we have got C1 and C2, so therefore the required solution will be y equal to, so C1 is 2, so 2 e raised to minus 3x. Now C2 is 1, so plus e raised to minus 3x. So that will be the required solution. And the next one, again we need to use the method of undetermined coefficients to find the general solution. So first we need to, so the general solution will be of the form complementary function plus particular integral. By complementary function we mean that is a solution of the associated homogeneous equation, and particular integral is any solution of the non-homogeneous equation. So here we'll start with y double dash plus 2y dash plus 5y equal to 0. So upon putting y equal to e raised to mx, we'll get the auxiliary equation as we did in the previous problem. We'll get the auxiliary equation as m square plus 2m plus 5 equal to 0. So this can be written as m plus 1 whole square plus 4 equal to 0. So m plus 1 whole square will be equal to minus 4. So we'll get m plus 1 equal to plus or minus 2y. So m will be minus 1 plus or minus 2y. So the roots are complex. So here the complementary function will be e raised to minus x, c1 cos 2x plus c2 sine 2x. So that will be the complementary function. Now we need to find the particular integral. So particular integral must satisfy the non-homogeneous equation. So on the right hand side we have minus 16 x e raised to x. Now here the derivatives of x will be, so if we take x, its derivative is going to be 1, and derivative of e raised to x will be itself. So when we write the particular integral, so it will have combinations of these two terms. So we can have a e raised to x and b x e raised to x. So this will be the this will be the form of particular integral. So it must satisfy these. So we need to find a and b such that it satisfies the equation. So let us say call this as y. Now if you take y dash will be a e raised to x plus b derivative of x e raised to x will be e raised to x plus x e raised to x, and the second derivative will be a e raised to x plus b e raised to x plus again e raised to x plus x e raised to x. So that will be a e raised to x plus b 2 e raised to x plus x e raised to x. So upon substituting this into the equation, y double dash plus 2y dash plus 5y equal to minus 16 x e raised to x we'll get. So y double dash will be a e raised to x plus 2b e raised to x plus bx e raised to x, then 2 y dash will be a e raised to x, then b e raised to x, then bx e raised to x, then 5y will be 5 a e raised to x plus 5 b x e raised to x. So this must be equal to minus 16 x e raised to x. Now we need to equate the coefficients on both sides. We'll equate the coefficients of e raised to x and e raised to minus x.